Porting Python code. As you know in watching these nuggets sequentially, which I hope you have been doing, you've learned many things about Python 2 just by virtue of some of those major changes between those versions, between 2 and 3. We know by now, for instance, that Python 3 is the first intentionally backwards incompatible Python version, and we also know that there's a heck of a lot of Python 2 still out there in the world, even going so far as to have entire web frameworks and GUI frameworks limited to Python 2 at this time. Therefore, in a really roundabout way, I'm saying that it's important for us to understand how to port Python code from version 2 to version 3. The main way we're going to do this is by invoking the standard library module 2to3.py, and it's a lot easier than you might think it is. However, no conversion process I've ever used is entirely automatic. We do have to be aware of some warts and some extra work that may be involved on our part. Let's get to work. If you spent some time at docs.python.org, in particular their What's New pages, you can read the design decisions that Guido and team put into Python version 3. What you're seeing on your screen now is a really nice comparison that I've put together between Python 2. The standard reference version of Python 2 is 2.6. As of this recording, the standard reference version of Python 3 is 3.1.2. But we can often refer to software with a generic identifier to denote the subversion, 2.x and 3.x respectively. However, as you're going to learn in just a moment, the Python Foundation strongly recommends that you do not attempt to port any Python 2 program earlier than 2.6. As previously stated, Python 3 is intentionally, in a sense, a reboot of the Python environment. According to the What's New documentation at python.org, the team has attempted to fix well-known warts, as they're called. Wart is a programming term that references an aspect of a programming language or development environment that just needs to be fixed. It's something that's a bug or just an ugly way to go. Another way to define a wart is cruft. Cruft is more specifically unnecessary code. Maybe you had a more roundabout way of doing something, and now in Python 3 it's much more direct. I'm really proud and grateful to say that we know of most of these major changes that you see. The print statement in Python 2 is now a function in Python 3. We've been using the range function a lot in Python 3. It returns an iterator object. We know that too. However, in Python 2, the xRange function returns an iterator. If you run the built-in range function in Python 2, you actually get a list back. So that's going to be a little unexpected if you're used to functioning with the iterator in Python 3 and then see unexpected output in 2. Range is now gone as far as a list output. You're going to want to invoke the built-in list function to convert your iterator to a list. In Python 2, there were two variants of the integer data type, long and then just standard int. Those have been conflated in Python 3 into a single data type. Integer division has undergone a nice change. This is an example of a wart. In Python 2, 1 divided by 2 yielded 0. It was straight integer division. In Python 3, 1 divided by 2 gives you 0.5, and as we've previously seen, Python considers both of these elements and the result as float. If you want to do straight integer division in Python 3, you just do a double /. We know also that strings in Python 2 were ASCII, much smaller code set than in Python 3. Python 3 is going to support just about every language in the world nowadays thanks to its Unicode default. Speaking of strings, you'll recall that in string formatting, Python 2 uses the C-style %string formatting. Python 3 still supports that, but the preferred way to go for formatting strings is to use the format method along with the braces. You remember how that works? Another gotcha folks who learn Python 3 and then attempt to do Python 2 find is that the raw input function in Python 2 is now input. Therefore, if you start with the input and try to use that function in Python 2, you're going to raise an exception. And finally, speaking of exceptions, you'll also recall that we can alias our exception as, say, E in order to bring meaningful exception data to our application. In Python 2, there's a comma in your except clause. In Python 3, we use the as reserved keyword. Finally, I want to give you a heads up on one of my favorite books. It's called Dive into Python 3 by Mark Pilgrim. The site is at diveintopython3.org, and you can buy the book if you really want to from A Press, but the entire book, both Dive into Python 2 as well as Dive into Python 3, is made available by the author, and he's really done us in the Python community a great service. In particular, I want to draw your attention to the first appendix, where he talks about porting code to Python 3 with 2 to 3. He also has a chapter where he does a case study on porting a Python 2 app to Python 3. So not only does Mark cover the process of porting code really well, but he does an awesome job, in my opinion, of very methodically going over the differences between Python 2 and Python 3 in terms of grammar, syntax, etc. Python Code Porting Overview. I've grabbed a little bit of text from the online documentation at python.org simply because these folks here in just these small paragraphs state the process better than I ever could, or just about anybody ever could, using this few words. According to the Python team, it's a 4-step process to port your Python 2.6 project to at least Python 3.0. You'll note that step 0, or the prerequisite step, is to start with excellent test coverage. We want to make sure that our Python 2.6 application starts off as STRAC as possible. STRAC is a United States military term that means effectively really on point, really tight, bug-free code. Once we know that the code is going in solid, you never want to take shaky, messed up code and try to cram that through an automated or even semi-automated, as we're going to do, conversion process. Some folks have the naive thought that doing this will result in a really nice application at the end of the conversion. No, that rarely, if ever, happens. That's a truism in IT for sure. Step 1 is to port to Python 2.6. So if you have an old code, like prior to version 2.6, we'll want to do porting up to at least version 2.6 and then do our 2 to 3 work, moving from Python 2.6 on up. Step 2, we're still using the 2.6 toolkit. We'll run Python with the 3 command line switch. That's a 3. And what this does is it enables warnings about features that'll be removed or changed in version 3. And I'm going to show you how this works in living color in just a moment. Now, the -3 switch when run against your Python 2 file is not going to warn you about stuff that the 2 to 3 utility can fix with no problems. It's essentially going to give you the deal breakers or the road blockers. Finally, in step 3, we run the 2 to 3 source-to-source translator. This is a Python 3 script, of course. We can run the result, manually fix up any remaining issues, and make sure all tests pass. You're probably wondering, from a theoretical or maybe even a practical standpoint, okay, this is cool, we can port Python 2.6 code up to 3. Do we have any options for backporting a Python 3 project to 2.6? After all, there are many, many development shops who are on 2.6. The answer to that is a qualified yes. You do a Google search, you can find the 3 to 2 project is coming along. It's still in a fairly early phase of development, but yes, there are folks hard at work at a backporting utility. Final slide before our demo, let's look at the 2 to 3 script in particular. As we've already talked about, in the Python 2 installation folder, we can run Python with the -3 switch to warn about blocker issues, and then switch over to Python 3, and we'll find in the Tools Scripts subdirectory of your Python 3 installation folder, you'll find a module file called 2to3.py. And what you see at the bottom of this whiteboard is a screen print of a command line run that I've done here, where I've typed Python 2to3.py --help to give us our syntax help. Bottom line is, at least in Windows, we're going to have to preface the 2 to 3 call with Python. In Linux, Unix, probably you can just run 2 to 3 as long as your environment variables are set properly. After your call to the 2 to 3 script, you pass in one or more command line options, and then you specify either a partial path, just the file name if the file is already in the scripts folder, or a full path if it's not. Now there's lots of switches down here. The 2 main ones we're concerned with is the L switch. That's not a 1, that's an L. And this is your non-destructive way to run a test on a Python 2.6 file. It's going to list available transformations. The other thing you want to do is, after you've done that and made a log of what needs to be changed, what will be automatically changed versus what you think you'll have to manually step in and do, you can run 2 to 3 script against your source file with the write or -W switch, and this does write the changes, but to a backed up file. If you don't want to do backups and live dangerously, you can use -N, although I certainly would not recommend that. Let's do some Python conversion, shall we? What you're looking at is a script file I've created called convert.py, adapted from an example at docs.python.org. And all it doesn't make a lot of sense practically, but it certainly does our example some good, is that we have a function called greet that accepts one argument called name. The name is the result of a raw input call. And I should have mentioned this, but we are in Python 2 here, of course. The first thing the user is going to see in this application, though, of course, is a print statement. And sure enough, we're using the statement and not the function, obviously. Enter a number. We then do a raw input and get that number, assign it to name. Now you know that when we echo that back here, by passing name into greet, the greet function is going to print hello number, and it's running a string format command. Down below, I've just done a simple conditional branch. If an int representation of name is not equal to 1, print sorry the number should be 1. We're obviously looking for 1 here. Otherwise, you guessed correctly. Now the reason why I added this is to demonstrate another difference between Python 2 and Python 3. This guy here, the not equals, less than, greater than, is now in Python 3, as you know, bang equals. Okay, let's run this module. Enter a number. I'll do 5. It says hello number 5. That's the result of the greet function. And then our if branch runs, and since name was not equal to 1, we get back sorry the number should be 1. Good and good. I've now opened a command prompt and navigated into my Python 26 directory, and as you see, I've run the dir command to show that we have convert.py right here. We're first going to invoke that -3 switch. Remember, if we run Python with the H flag, it gives us a lot of help and tells us the -3 flag warns about Python 3.x incompatibilities. So therefore, we'll simply type Python -3 convert.py. We get only one problem here. Now you have to remember that Python 2 to Python 3 changes are dependent upon the specific subversions. So you noticed, I'm sure, when I showed you the source code, that we were using the brace and the format method to format that string, and you might have expected that to blow up. However, that's evidently been added into this version of Python 2.6. If Python does detect deprecated elements, things that are not going to be trivially fixed in 3.x. It tells us, and that's what this is saying right here. Deprecation warning, less than, greater than, not supported. Use bang equal instead. Finally, I've opened up another command prompt, navigated into Python 31 tool scripts, run a directory listing. There's our 2to3.py module. And to invoke this bad boy, we'll just do a Python 2to3.py. Actually, why don't we run that with the help switch just to see what we've got going on. This gives you the help that I showed you in the previous whiteboard. So there's nothing to see here. Without further ado, let's get this code porting done. We're going to call the 2to3 script first with the L switch. I'm going to non-destructively just list out those fixes. Then we'll pass in the name of the script, convert.py, and I'm actually going to redirect this to a file called refactor1.txt. Refactoring, by the way, is a programming buzzword that refers to modifying your source code. Certainly, porting from one version of Python to another would be an instance of refactoring. Let me adjust the window here to make it easier for you to see. The reason why I outputted the results of that operation to a file is because otherwise the list is going to just go to standard out. Alright, so first we see a list of available transformations that the fix option can undertake. You'll see a lot of these are actually module names. If we scroll further down in the file, we can see really the meat and potatoes of the 2to3 process. You're going to see that lines that are denoted with a minus sign denote the original code, and then plus lines are refactored code. You'll note here on this plus line that the old call to the print statement has been changed. The format method was available in Python 2.6.4, still available in Python 3, so that was left alone. Now you notice that raw input has not been corrected, so it looks like we may have to fix that manually. Yeah, because you'll notice that they just, by they I mean the developers of the 2to3 script, have transformed that line into a call to print. We definitely don't want that. And then in our if block, the if statement where we look at not equal to 1 has been changed here, and then it fixed the print. Alrighty then, let's now come back to our command line environment. I'll up arrow to give our previous statement focus again, and this time instead of -L, we'll do -W. Because the W switch is also non-destructive, if we come back to the file system, you should see that we have our converted convert.py, which I'm going to call convert223, and then we also have a backup of the original file that 2to3 created and gave it the back extension. So now we're free to right-click, edit with idle, and see what we need to do with that file. Here's the refactored code. As expected, we're fine with the switch from the print statement to the print function. We've switched the not equal to, but of course we're going to have to substitute this guy to, actually, why don't we just copy this or cut this and paste it in the input line. It was nice that the 2to3 did give us this. And it looks like everything else is fine. Good deal. Let's run. Cool. I guess the icing on the cake here is to make sure our converted refactored code functions in Python 3, so let's open the run module, guess a number, and we're fine. The code works in Python 3. Mission accomplished. Porting Python code review. In this nugget, we looked at the major differences between the Python 2.x code tree and the Python 3.x one. We then looked at the method formally given to us by the Python Foundation for porting code from 2 to 3. We understand now how to use the -3 switch in our Python 2.x installation folder, and then use the 2 to 3.py library in our Python 3 installation folder to take care of, as much as possible, an automatic code port. But we also know that, especially depending upon the complexity of your source code, you've got some manual cleanup to do no matter what. I hope that this has been informative for you, and I'd like to thank you for viewing.